Okay, so we've got a walker here who's walking with constant velocity and we want to find the speed. Now remember, speed isn't a vector, it's a scalar. So we're going to Pythagoras this. So we're doing the square root of 1.2 squared plus 0.9 squared, which gives us 1.5 meters per second. We've got a horizontal field as shown above. At 12 noon, walker H is at a point Y. Relative to the fixed origin, we're going to write a position vector. So when we're doing this, we're saying, where is he starting? So he's starting at Y, so at 100J. Now, every single second, he is walking 1.2I minus 0.9J. And we want to, this would be your position vector. But what you're going to do is you're going to write it, all the I's together and all the J's. And we're used to having the I's first and then the J's. Okay, so it's a walker and that is this position vector. Now what that means is effectively starting here, every single second, it's as if he's going 1.2 along minus like that, but he's not really doing that. He's going along that diagonal. So that's what that represents, where he is at every second. Okay, now we've got another walker, and at noon, this walker is at K is at 9I plus 46J. And every single second, he walks 0.75I plus 1.8J. You could have written this, if it's easier for you to see, as a column, right? And then you can put your I's and J's together. 1.8J. Right. We want an expression for the distance between them. So essentially we want to go from W to K. Now you should know whenever you have that, you're doing the second one minus the first one. So it's vector K minus vector W. So I've got 9 plus 0.75 Ti plus 46 plus 1.8 J. And I am minusing the whole of the previous bit. So 1.2 Ti plus 100 minus 0.9 Tj. So that's from over the page. Now we can only minus I's from I's. So we've got 9 minus 1.2. 9 on its own, because there's nothing to minus here that doesn't have a T next to it. So we've got 9, and then we've got 0.75 minus 1.2, so minus 0.5 Ti, plus 46 minus 100, which is going to give you minus 54 plus 2.7 Tj. Now, show that they meet. Well, when they meet, that distance between them is going to be 0. And the way to show that is we work out what happens when the I equals 0 and check it agrees with the J equaling 0. So when they meet, WK equals 0. If I rearrange that, I'm going to get 9 equals 0.45 T. So T equals 20. If I sub T equals 20 into minus 54 plus 2.7 T, I should, if it's correct, get 0. And if that will prove that they meet. So equals 0. So they meet. Now where do they meet? They meet when T equals 20, sorry. So we're going to sub that back into either one of these original ones. So when T equals 20, so if I had 100, I had 1.2 Ti plus 100 minus 0.9 T. And I'm going to sub in T as 2. So I'm going to get t is 20 even, not 2. So I'm going to end up with 24i and plus 82j. So that is my position vector of where they meet.